Okay, hello everyone. This is part 2 of our discussion about entity qualifiers. Yesterday, bizarrely, I had gone for a walk and I was lost in the woods when we were talking, so I wasn't quite as efficient as I hope I usually am. All right, this is part 2, and last time we didn't get a chance to cover some of the comments that got made in live stream chat. And we'll probably come to those today. Okay, so let's talk about what we had figured out yesterday. So, and I assume that this is not any different from what we talked about yesterday here.
Yeah, it's just the comments that were added and the last section. So.
Okay. All right. Last section on qualified value array.
Yes, proposal. It's like time series, but for any number of qualifiers.
Interesting.
Temperature pressure series.
Right. And how would you plot it? Would list plot just work on it?
That might be asking for a lot.
Well,
because
how else would
like the main thing would be like, would list plot make the decision between a set of curves or a surface? Or is list plot implying it's a set of curves?
Oh, no. I mean, that would be, well, let's try to understand what's in this thing. So this is a mapping. Do we have anybody from the graphics team here?
No.
Let me see if we can find Brett.
I can find him.
Okay. Okay. But roughly what this is a mapping. I'm a little confused by what this is going to be.
Yeah, so sorry for those short examples. Those are more like development notes in a short amount of time. But the idea is that we have a constructor that basically encapsulates a list of the qualified values that we've seen yesterday, and restricts what can be in the list. For instance, the qualifiers need to be compatible. That means you have some notion of...
Yeah, I understand. Okay, but let's look back up here at the summary. Okay, so let's remember what we have right now. All right, so we have entity instance, right?
That's the nearest one, yeah.
Okay, and entity instance can take as a second argument a variety of qualifiers.
Right? Yeah, maybe two types. It can take things that later on get propagated to the corresponding property, or it takes quantification arguments for elements and chemicals.
Or this.
This is yet another special case when a property returns a function object. Then we can
okay, well, fine, but I mean, it's a okay.
Right, that's a different case. I would say 50% a different case, because there is a property parameters of this entity type, but it's more baked in.
Well, I don't understand. Okay, I mean, this is another case here. These all look like reasonable cases to me. I mean, where's your case with amount of chemical? Is that under scope?
No, here the last example, specify mass of a substance.
Oh, okay. Okay, so then I can say for this, you're asking for absolute volume there, but I can just say the entity instance.
You could ask for the mass or for the amount of substance or something.
Is it obvious that that shouldn't have a special print form?
No. I mean, this comes back to this discussion we had yesterday. quantity of in the Wolfram alpha code is more natural descriptive. Of course, with a print form, we would partially work around this for output.
Okay, right.
And then there's the nesting problem of this solution issue that we discussed yesterday.
What's the nesting problem? That
We
within
have,
the solution, you have
first we make a solution of a certain molarity, potentially even multiple solutions mixed, and then we have a total amount of them.
Well, I think that that's just the chemical solution thing has as its slots entity instances. I don't think that's a problem.
But this will not do because the molarity is not a qualifier of the things together. It's the combined of two. And because of nonlinearities, we cannot switch the outer with the inner. It's not commutative.
Okay, I understand. But I mean, so here what you would be doing is you'd be saying the molarities, in principle, you'd be saying the molarity list, molarity 1, molarity 2 of each of these. And then the whole object.
Sorry, there's not yet a proper entity instance because what currently is in a slot entity instance would be a mixture between solvent and object to be resolved.
Okay, fine. So this is like you're dissolving tungsten, which probably doesn't dissolve
in gold.
In hydrochloric acid. No, whatever. Okay. And then the chemical solution would specify molarities there.
Yeah.
And then it's an instance of which says, mass arrow 5 kilograms or something.
Right.
What's wrong with this? I mean, if I understand
for a computer, nothing. For a human, my understanding from the two JSONs is it reads very strange.
Okay, well, let's get them on the phone here.
They're here.
They're here. So I thought, to me, the only problem was that you have an entity instance where your first argument is not an entity.
Okay. We'll worry about that in a minute. Okay. Okay, so that's your only problem with this. Other than that, semantically, it means the right thing. Is that correct?
So, I mean, it means just there are 5 kilograms of the thing that is the first argument.
Yeah, that's right. That's fine. It's fine.
For that actually to work, we'd need to carry around density somewhere, but that may be a separate issue.
I'm sorry. So wait a second.
So the molarity is a amount of stuff per volume, and then you've got a quantity specification and mass. You need the density to figure out convert between the two.
No, I understand that, but that's something that. But
this was already the case in this example that Stephen copied over.
Oh, okay. Just make sure. Sorry.
Yeah, for doing basically non-trivial properties of the thing, we might need additional information.
Right.
Okay, so let's just write down the. Okay, so this is the Wikipedia version of this, where we're saying external identifier. So this is now just an arbitrary qualified value.
The one thing that I was wondering about this, and we had this discussion a couple of months ago, it is qualified and we get this additional information that kind of is partially specified in the input, but at the same time, we lost something. We lost the information about refractive index. So I was actually wondering if we should preserve everything.
For what? Where?
In the result, like we have a data blob or something like this. Like we know, like this 1.32524 belongs to the wavelength 2013, but we have no idea anymore what it is on its own if we forget the input.
No, I understand, but many things have units which tags them, but refractive index happens to be, I mean, if that was a pressure, it would be at least a pressure unit.
I would say it gives a hint, but there are many things like stresses are measured in pressure units.
Sure.
So there could be a result form like data statement that returns, well, data statements of the entity, the property, and the value corresponding to it.
Well, I mean, okay, so you've pushed this before, Tony. This idea of some kind of statement that makes that's so deeply, semantic web. That's basically a triple, an entity property value triple.
Yes.
I mean, it's just not the nature of our kind of system to maintain.
That's correct.
All that stuff. We just,
right.
We make forward progress. We don't store everything. But I don't understand why in qualified value, if we chose to, one of the qualifiers couldn't be, one of the potentially ignored qualifiers couldn't be something about what the source was. What kind of a thing it is. But let's take a look here at, we've got two concepts here. We've got a qualified entity. Okay, so our concepts are qualified entities, aka entity instance. Now we've also got things like entity group, which is a different thing again.
Yes.
Okay, so qualified entities, and those come in two kinds of qualifications. They are subcases of entities, and they are things like amounts of entities. And they're also things, well, subcases of entities could be date, time, whatever. Now, depending on what the kind of an entity it is, there might be a meaningful amount or that might be meaningless.
Correct. I would argue that, say, the dated, which is the time one, is a version of subcasing. But if we would have the yesterday shortly mentioned geoplaced one, I don't think it's a subcase. Like if a person is at a certain place, I feel like it's still the same person. It's not a subcase of the person.
Oh, but I don't agree with you. I think that it's sandstone from darkest Utah or something, right? That's a geoplaced sub, in other words, if it's geoplaced of, let's say sandstone, right? That could absolutely be geoplaced to, or actually a better example is a geoplaced isotope that's different in different mines. See what I'm saying?
Okay, yes, but that's not what I had in mind. I was thinking you were thinking like we have a concrete entity, say typically a person, and we move the person around.
Okay, so look, there's the entity exists. Boy, this is going to turn into philosophy very quickly. The entity exists, and we are describing its environment. That's one case. Okay, so an example of that would be position in space, temperature, could be time. Sometimes it's time, but time, okay, the real question here is, does the thing change its character as one of these properties changes? Or are you merely moving it around, heating it up, whatever, but it doesn't change its character? So for example, with temperature, ice versus water, right? Ice at standard pressure at a temperature of 50 degrees centigrade. Does that make any sense? Probably not. What is that supposed to be?
I think that's an excellent example. It's probably possible to get it metastable in the state.
Sure.
So in some sense, it does exist.
Okay.
And it has probably some very interesting physical properties.
Indeed. Okay. What about the Roman Empire in 1960? Does it exist?
Missing counterfactual.
Okay.
Well, some of the land that was the empire exists.
I know. But that's the point. I mean, that's you know, right. So that's the issue. Is okay. So one case is the entity exists and we are describing its environment. Another case is we are, the entity is parameterizable. And we are describing
I don't think we are describing its environment. We are describing its environment together with the zeroth law of thermodynamics. We assume the entity is in equilibrium with it, because otherwise we need yet a new set of
fine.
Okay,
we're describing its state.
Yes, its state, not the environment state.
Yeah, fair enough. Okay, we are describing a case of it, e.g., gold in a sphere, of radius 5 centimeters.
Right.
Or, so, I mean, one interesting question for any of these entities is, does it exist in the world? We could have a, exist IRL queue, so to speak.
I mean, we have fictional characters as entity type.
I understand. Oh, boy. Yeah, does Star Trek exist? Well, yes, it's a television program, but it doesn't exist, I mean, this is a question. Does it exist in real life? Like a sphere of gold the size of the sun probably doesn't exist in real life.
I see your point. I don't think it's a sensible question, because like the sphere of gold, what does existence mean? Like, is it stable with respect to becoming a black hole, or that gets a very
okay. But there's another example, which is if I'm taking a sphere and I've got a parameterization of the sphere, and I ask for something, a parameter value outside the range of parameters, which is, I think, very similar to asking Roman Empire in 1960.
Yeah.
Okay, so this would be, something like, longitude 450 degrees. Is it just, it doesn't exist as a matter of, definitionally doesn't exist. Okay, so go ahead.
This concrete one probably would work, because sometimes
I know it loops
good.
around.
Yeah.
Latitude 450 degrees, I think,
yes,
would be more problematic.
Yeah.
Maybe this question could be decomposed in the first step is having an identifier or minting one, and then finding an object that actually refers to that. It's like writing down an ISBN for a book that hasn't been printed yet, or inventing an ISBN.
Yeah, I understand. Does it resolve into something real?
Yes.
Well, actually, all we can say, does it resolve to something we know about? Something real or something we know about? Because maybe all we can say is it doesn't resolve to something we know about. The sphere of gold the size of the sun might resolve in principle, but it doesn't resolve to something we know about. Okay.
Would it matter for any questions that we can ask about this object?
Potentially. Okay. I don't know. I mean, look, the Roman Empire in 1960, what's the population of the Roman Empire in 1960? It matters that it doesn't exist.
Right. I mean, there's the difference between computed properties and looked up properties, measured ones.
Yes, but that's a fine line when we do interpolation.
Yes.
Like ice at 50 degrees centigrade, we might very well be able to, extrapolate its electric resistivity or something. Well, let me give you an example. Ice at 50 degrees centigrade, say crystal structure. That's a little funky, but we could imagine that that would be determinable. All right, so again, what we've got here is a collection of qualifiers to a thing, usually an entity, a concrete. You know, I wouldn't be that horrified by using entity instance, even though there are cases like this where it is not truly an entity because it is based on entities. I mean, I wouldn't be okay using this if the thing we had inside was purely abstract. So you're saying a molecule, for example, is not really based on an entity. Is that your point there?
Yeah, that was one of our points that Jason raised yesterday. And there the question of existence becomes extremely hard.
Sure. It's completely unknown. So, okay, so, all right, so we've got this notion of a qualified object, and then we can subcase the object, we can talk about the amount of an object. Then, for both of these, it could migrate to the property. It can either apply to the property or to the entity, and I don't think it matters much, does it?
Now, yeah, for the amount, there isn't a natural property. Like volume is not a property of gold, but once I have 10 kilo of gold, I can speak about its volume. So there's a property that didn't exist before.
How are we going to deal with that?
Right now, we have a small hard-coded list of things that are
okay, so
outside
this
of
is
the scheme.
Properties that exist for certain instances, but not in general.
Correct.
E.g., volume for 5 kilograms of tungsten or something. So these are necessarily not necessarily computed properties. No, it could be, will it kill an elephant or something, which isn't really a computed property in the sense that it is, well, I don't really know what it is. Okay, so that volume thing, so what you have is a set of additional properties to an entity that only apply when the entity is instanced.
Right. And I mean, we did this because it felt natural, but it is not obvious that is 100% the right approach because there are very few entities that are of this type, like elements, food, chemicals, isotopes, where we have this slightly abstractum substance-like object, where, like, for people it doesn't apply in any form.
Well, okay, so look, there are continuously quantifiable things, e.g., substances. I mean, there are slightly complicated things like strawberries, for example, right? There are individual strawberries, 7 of them, and there is a certain mass of strawberries, a continuous number, but might not be realizable in an actual collection of strawberries.
Right, but for nutritional things, you're probably interested in how much is in 100 gram rather than in 9.47.
Okay, but let's take money, okay, with coinage. You know, $13.724. Perfectly reasonable quantity in terms of calculations, but not realizable in terms of coins.
Right.
So, yeah, I see.
I mean, because they are units, they kind of circumvent this problem.
Okay, so another thing that's continuously quantifiable. So you're saying, okay, so one continuously quantifiable thing is units. Units are an example.
And time, dates.
Okay. Okay. Dates, substances, but I think there are others. I mean, I mean,
Now, there are some that in the middle, like what we had earlier, like a circle as a geometric thing. Its radius is continuously quantifiable.
Right. But I'm thinking about other things which you might not think of. I mean, you see, there are things that are discretely quantifiable, like number of sheets of paper. I mean, they're okay, continuously quantifiable, then they're also discretely quantifiable.
So with other words, countable.
Probably countable. I mean, okay. Yeah, I mean, there's even more cans of worms here. Like we talked about geoplaced, and clearly weight depends on geoposition. Mass does not, but weight certainly does.
Yeah. And while not a big effect, but if we speak about, say, a couple 100 million years, even on time.
Sure. I mean, and also the geoplaced, I mean, you know, it gets really funky, right?
Yes.
If we're dealing with, you know, well, the Earth's rotational poles presumably don't move, I assume.
I don't think so, but the speed changes.
For sure. No, but the can of worms, if the poles moved, for example, for a tumbling asteroid, for a tumbling asteroid, you're out of luck. That's specifying lat long on the asteroid.
Yeah. But this I feel like a little bit too far off from our main entity uses.
It is for now. Okay, but anyway, let's okay. So the basic point here is there are lots of ways that one can, so there's quantifiable and there's instanceable things, which is, I think, what you've, I mean, that's what you've basically identified previously, right?
In my opinion, these are the main things that currently are subsumed in entity instance.
But instanceable potentially includes geoplacement and time, yes?
Yes, because the position could be a qualifier. And there's one example, like the rise time of Mars depends from where you are on Earth, for instance.
Okay, but I mean, like the qualifier, like, for example, sun position presumably should be able to take, oh boy, how does that work?
Okay, this is a function, again, it circumvents the problem. But as Tony said, Mars as an entity has a property rise time, and then we need to say from where.
Yeah, I understand, otherwise it couldn't say anything. Okay. All right, so you've identified these two things, and the question is now, when a result comes out for a value, do you tag? Sometimes you, okay, so the other issue is, so that's putting things in. Now the other issue is what comes out. You know, single value versus a collection of values versus some function versus something like an average applied to multiple values, etc. Right?
Right.
Also annotations saying, like, you know, how much of the data was missing, things like this. Annotations like, what was the minimum measured temperature? What was the maximum measured temperature? All right, so what you've identified here is this idea of a qualified value, which is not something that we usually do in the system. That is, usually, I'm not that keen on this. I mean, I think time series is a fine thing, but this idea, I mean, usually we get a result. The answer is 1.2 kilograms per cubic meter. Boom, that's it. The only case where we want something different is when we have something which we're going to compute with later, I think. Did Brett come here, by the way?
I haven't heard back from him, and I don't see him in the participants.
Okay. All right. So what I think, I mean, again, I don't believe in this one. I don't believe in this. I think what I would believe in is this kind of qualified, something like qualified value array. And so what that will contain, much like a time series. So let's remind ourselves what a time series contains. A time series can contain date arrow value, right? Date arrow value, etc. Right? And then it's wrapped with an event series or a time series. By the way, notice those different concepts of event series and time series. Right? An event series is a discrete thing, and a time series has tried to interpolate it. Make sense?
Yes.
Okay, so we have both those concepts in the case of time, and they're useful, right? So, I mean, to me, I almost feel like it should be called something like data series. And the question is, how does data series relate to interpolating function and things like that? I mean, this really is a data series. That's what it's about. That's the case that we care about here.
There might, maybe with one modification, time is always one-dimensional. It might well be that some of the qualifiers are multidimensional.
That's fine. I think a data series, in pressure and temperature seems sort of okay.
Okay.
So then what would happen is a data series. So, I mean, what we could imagine there is many of the time series operations being supported. So if we remind ourselves what some of those time series operations are, there's a lot of things. There's a lot of stuff here. And
that's not realistically reproducible for generic cases.
Well, a moving map is certainly reproducible. Mean, histogram, those kinds of things are reproducible.
Yes.
But maybe only in the one-dimensional case.
No, look, mean is reproducible for anything. It's just the mean of the values, whatever those values are.
And again, what Tony had showed yesterday, that sometimes the qualifiers are categorical.
I understand that, and that might be relevant for things like categorical distribution, because, for example, we might say for data series, I mean, how would we get, given the data series, we want a distribution. So, for example, I would imagine we can say empirical distribution. For a time series, we can presumably say empirical distribution of the values. Is that a true statement?
If not directly, then with one more.
Yes, we can. Yeah. Okay. And categorical distribution is also a perfectly reasonable thing to ask for. So,
but sorry, so I think that's we look at two different sides. The empirical distribution would work on the value, where the categorical distribution might be categorical with respect to the value of the qualifiers. not the value of the sink.
No, but the empirical distribution is also. Oh, I see. That's just the histogram of values.
Yeah, left
Okay,
or
so
right
there's
side.
a different issue, which is the empirical distribution. Also, the empirical distribution of temperature values or whatever, empirical distribution of density values, for instance.
Yeah.
Wait a minute. That's complicated because that involves interpolating the value. No, I'm confused now. Okay, so let's look at. All right, so we've got this notion here. Okay, so let's go back again to how we're getting these things in the first place. So there's two things. Okay, even for an existing thing today, we could imagine asking for, population of Italy, right, which is our standard Italy population. Now, right now, we say dated, comma, all. And that rather hackily returns a time series, right?
Yeah.
So in general,
because it's useful, but it's not quite literal. Yeah.
What's that?
It's very useful, but it's not 100% literal, I feel like.
No, that's right. Right. But so let's give another example. Let's say tungsten, and let's say that we say
density.
No, I've got a different idea. This is a bad name. Is that what I want? No, it's not what I want. I want it as a property, right?
Yep. I don't think pure property passes in this form.
Okay, well, whatever. Okay, so let's say I write density here, okay? And then I was to say all here. What I would want to get out of that is a data series that has, with all of its qualifiers, pressure, temperature, whatever, isotopic, whatever it is, right? The whole story of this, if that makes sense.
Yes.
Yeah, it would be.
I mean, and this would otherwise say, density, temperature, arrow, 1,000 degrees. And that would then return a number.
Right.
Value, whatever, with units. So there's a direct analogy here. I mean, this is a slightly hacky thing, and we need to understand what its precise semantics are.
I mean, technically, this probably can work. I find it slightly unnatural from the viewpoint. It's not a density data instance. It's a tungsten data instance. And as we discussed yesterday, so it should be flexible with respect to moving the instance over to the head.
Fine. So, I mean, that would be instanced, it's a bad name, but instanced of tungsten, comma, all density. It's fine. And that would also return a data series.
Yeah. I mean, potentially just, yeah. It's nearly more like a value set, like series implies to me a certain amount of orderness.
There will be an order to it most of the time, unless it's very categorical. By the time we call it data collection or something, it's kind of lost the game.
Yeah, I agree.
Now, the other issue is, let's say we do this, but we want it to be somehow aggregated across, let's say we want the mean around of these things. We could imagine something like that, possibly. that's the aggregator. So we've already got a concept of that, right? In the case of air temperature data, for example, we have that notion of an aggregator, don't we?
Yes, we do.
How does it work? Well, we've got these particular, oh, I see, func, right. Right, so that's an example where there's an aggregator, which is the same kind of idea as this. Now,
which by itself is a version of the current entity value.
I see. So entity value, you're saying if I say entity value Europe, oh, countries in Europe probably. Okay, then I say population, which I think will work as a,
yeah.
And then I say mean. I'm confused by that. Okay. So now if I were to say, for example, there, I would say empirical distribution, for example.
That will probably not work. I would be surprised. Oh,
it worked.
Nice.
So now what I would say, I'd say histogram of that, presumably. Is that what I'd say? No, I would say PDF of that. Plot the PDF of that. I don't know for what range of things.
For searching, it would be nice if plot would just take what's there.
Yes, right.
Same for interpolating functions.
We should discuss that. Right, that's a separate thing. Can we,
Yeah.
Ben? I think that's a separate discussion. Okay, so what we're saying here is that we've got this notion of the entity, the property, the aggregator. So in this case, what we've got is the qualifier, the value, the aggregator.
The question might be how that generalizes to multiple qualifiers. How to apply different aggregators to different qualifiers, if that makes at all sense.
Yeah. Well, I think I'm not sure you can do it in one go. You might have to do it in several pieces. Let's see. Okay, so let's look. What is this? This is how you do it in Entity Store.
Yes.
Okay. So let's look here.
I think Brett just joined.
Yep.
Okay. This is another can of worms. What's happening here? So this would turn into, in our modern version, it would turn into a data series. It's not completely crazy. A data series which says, well, that's crazy, okay? Because that's a qualifier associated with what kind of a head of state it was. Right, which is a different thing.
But then what we said earlier, it's a little bit flexible which of these qualifiers belongs to the entity and which to the property.
Sure, but I'm saying in the output, if it's a data series, the data series here would be, start time, blah, blah, blah. This is basically saying with this bag of things, it would turn around and it would say, this
Right.
association, arrow, Harold V.
Yes.
But this is then an utter can of worms here. Because what we'd ultimately want is something we want to get out from that data series. We would want to extract the time series of values, for example. See what I'm saying? So we might be able to do that by just saying simply time series. And it might just get that out of this by looking at, I mean, probably not for the Wiki case, but for our own cases.
For our own one, we know what kind of dates we have.
Sure. But I mean, even in this case, we could say extract from, so
it's kind of dimension reduced de facto.
Yeah, operations on data series. Okay, so then what we would do is we would say, so for example, you might say time series of the data series, or we might say,
project data series, comma, property.
yeah, data projection, bad name, but data projection of data series, and then with respect to pressure, for example.
Yeah.
Actually, we could even have...
We might get a small problem with this, like we would have multiple values for the same point, which interpolating is not so fan of.
Indeed. We also probably will want to be able to select on the right-hand side, so to speak,
Right.
for a particular pressure value. You know, so it might end up being pressure arrow value of some kind. So this would say project with as a function of pressure.
But it would imply determining default qualifier values for the other qualifiers.
No, it takes all. No. It projects every single one down.
Yeah, so what it would look like, the data structure you get at the end would be a data series of, and this is where Brett is about to come in, because this would say, I don't know what the structure looks like exactly. It might be a pressure, no, because we want to have multiple ones. It might end up being a pressure value 1, arrow.
Now that's only the value.
Yeah, okay. Oh, I see. What this has done is it's projected down to pressure.
Yes.
And if I'd said pressure, comma, temperature, then what I would have got is
2D.
A 2D thing. So that what that would look like is, if I say pressure, comma, temperature.
It would make pairs on the left-hand side.
Exactly. Okay, Brett, given a structure like this, how would you plot it? What function do we have that will take? So even in this case here, presumably list plot could be made to deal with this.
The list plot could be made to work with that. In the second case, you're probably looking at the list plot 3D, list density plot, list contour plot, family of things.
It might be a little bit more involved, like the right-hand side might be vector, so we might want to have a stream.
Well, I mean, I think in general, the list family of plotting functions.
Yes, exactly.
Okay.
I mean, additionally, there would probably, we would probably extend it to like even things like histogram, where it would ignore the left-hand sides and just operate on the right-hand sides.
Yes.
But we said earlier, sometimes we actually, yes, I think that's the default, but sometimes we might want actually to get an impression about the right-hand sides.
What do you mean? That's what
sorry, the left-hand side. Like, I want to know like which pressure temperature values were used.
Yes. Well, then we'd have to have something like keys of this or something. Possibly some kind of mechanism like keys of that goes to pressures. Okay, let's zoom out for a second. We've got a bunch of comments on our live stream. Comment from SWSH. Classifying and abstracting over types of properties, continuous versus discrete, bounded, unbounded, dense, ragged, sparse, interpolatable, ordered, measurable, and so on. Classifying and abstracting. I see, I'm not sure. Right, I mean, we have functions to deal with all these different kinds of things. I mean, in a sense, the question is, what are you going to do with it? And for example, let's say bounded versus unbounded. We don't know whether the, let's say, I don't know, the height of a tree, is it bounded or unbounded? I think it's difficult to know this. Okay, let's come back to, so Icy said earlier, qualifier value could be a wrapper that has different visualization, like a round. Yeah, I mean, it's kind of the footnoted values thing. That's another can of worms. I mean, okay, so let's talk about footnoted values and whether there's anything useful we can do with them. So let's imagine that, I mean, I'm just going to use the term footnoted. It's not a very good term, but I mean, let's say it's a value and then it has all kinds of junk here, right? That represents its footnote array.
The gray text in alpha.
Exactly. So the question is,
what's the gray text in alpha?
Oh, it has qualifications like
population in 2008.
Gotcha. Okay.
So the question would be, could we generate this routinely as an option for these functions that it carries along like your qualified value thing, and then when you do an operation on it, it just blows it up. It gets rid of it. So if you say divide two footnoted things, sorry, the footnoting is gone, but the division works. I mean, in other words,
how is this different from the current annotation? At least according to the current ref page.
I'm not sure it is. Maybe that's okay. What it is. But I mean, so let's imagine that we say annotation. Okay, so let's say we have annotation 6.7, comma, blah, 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 divided by annotation 8, comma, blah, blah, blah. Okay, right now that's not going to do anything. What the heck did that do?
Annotation doesn't show the blah, blah, blah. It just shows the 6.7 and the 8.
Okay, but so fine. But it could be the case that there's some form of the annotation which would show as a gray, whatever it is. The issue is, when does the annotation drop off? And that question arises in graph theory stuff. The color of when you union, I mean, this is the calculus of annotations for graphs, right? The question is there a similar calculus of annotations for data? Because for graphs, you take two graphs, one of them has red vertices, one of them has green vertices, you union those two graphs, or no, you intersect those two graphs. What color are the vertices? Answer, I don't think they have any color at all right now. The annotations drop off in that case. Does that make sense?
Yeah.
So similarly in alpha, what we have is this notion of details where there are annotations, but the main result is just the result, if I'm not mistaken. In other words, we do aggregate a source annotation for the things that went into the result. Boy, I'm obsessed with causal graphs these days. It feels a bit like that there's a certain set of inputs that are needed. There's a certain set of things on which this depends. Well, the question is there a value to having this footnoted thing? And what would its semantics be? So one possibility is footnoted. Okay, so one possible semantics is footnoted survives only in inert functions. So in other words, if you have, footnoted in a list, it's a happy camper, right? As soon as you square the footnoted objects, they're not footnoted anymore. See what I'm saying?
Right.
I don't think that's a completely stupid thing. I think that could be quite useful, and its semantics is quite simple. If we say it evaporates anytime it's not in a list or another inert structure. I mean, so for example, it could be in a graph, for instance. That will be okay.
There's potential problems. What about inert structures like graphics primitives? They are inert, do typically no evaluation. So who will evaporate them?
Why do they need to? Oh, I see.
Because
So
they make trouble down the line.
Yeah, you're saying point of footnoted.
Yes.
Whatever.
Exactly.
Well, that would have to be a piece of code. I mean, what does it do for around?
That case is easy.
Okay, good.
I
That's
mean,
your team to deal with that. But yeah, okay,
I mean, it evaporates during typesetting.
What does it do for around?
Nothing right now.
So point of around will just fail?
I think so.
Okay. All right. So
right,
I mean,
but the thing is like, the graphics primitives, there's one place where we add a rule and it happens for, all, whenever, whether it's point or circle or disk or whatever, it could evaporate relatively straightforward.
But you then don't want to really evaporate. You only want to evaporate it on typesetting.
it's not going to disappear. It will stay inert, which is the right thing. It will only evaluation can actually do something to the expression. And that's fine. If this is squared, then the result will just evaporate the footnotes. Okay, so let's go back.
There's probably still another 1,000 functions or classes of functions.
I see Ida not being happy with this.
Well, let's explore. I think it's not a completely stupid concept. I think it's a useful concept. And I think it actually dovetails with another idea, which I maybe don't want to discuss right here too much, but the other idea is, given f of g of h of x, okay, you could represent that as the graph, whatever it is, f goes to g, g goes to h, h goes to x. Yeah, it's badly drawn, and I should have drawn it on the edge labels. But you understand that that's, a block diagram-ish way of representing this. Okay, so I have this new idea because we're trying to merge a code and variables version of neural networks with the version that involves layers and blocks. And the idea is to have something like this where you can wrap one of these things in a thing that's called, I don't know, Nodify or something, bad name, that basically can make a version of this in which that is identified as a node in an evaluation graph. I don't know whether this is relevant. It's probably not relevant to this. All right, let's come back. There's a question from Andre on the live stream about extrapolating different time scales on time series. Yes, we can absolutely do that. We can't do that in general for an interpolation. I mean, with time series, we can do it at different granularities, because date objects, unlike numbers just have a precision. Date objects have a granularity, like daily, weekly, minutely, whatever. Okay, let's loop back to the original questions. Okay, so I think what we're concluding is there is an instancing mechanism that probably should be generalized beyond a name specific to entities.
Right.
And there may be some convenience functions like dated, of which the only one that I've seen so far is geoplaced. I don't know any. Well, maybe amount somehow. I mean, I could imagine one more sort of convenience function. Let's see. So dated, clearly useful. Geoplaced. That may be too complicated a concept anyway. Geolocated. I'm not sure. Geopositioned might be better, given that its geoposition is is the thing. Okay, so let's say geopositioned. Then something like substance. It really would like to be a past participle like that. Well, let's say, amount quantified or something. Bad name, but something like that. And those are the wrappers.
And this would allow not just for moles, this would in principle also allow for mass and volume.
Absolutely. Okay. Yeah, amount in a general sense.
Yeah, not in the sense of the SI.
Well, so it better would be like substance quantified or something. But it's not the right term. It's not the right term. But anyway, that would be one of these continuous substance type things. That's not going to work. It's not going to work because then you have the 10 strawberries problem. Because you would like it to be the same wrapper that says 10 strawberries, as to say, unless that's an entity group or something, as to say 10 grams of strawberries.
But that would be not a problem because like 10 grams is a unit and 10 items is a unit.
I see. Okay, so and then 10 might just default to the 10 item case.
Right, but I would prefer items, slices, and for food we have so many of them.
Well, fair enough, but there are elephants. 10 elephants.
Right. Okay. Yes.
Okay, so then the concept would be there are these convenience functions, and there's an overarching function that's called qualified or whatever it is. I need to go in a few minutes here. So let's just try and okay. So what we're Ethan on our live stream is suggesting amounted. It's kind of hard. Yeah, quantified. The problem with quantified is it's because of quantifiers, like for all and there exists. Who invented that anyway? Was it Frege? Who invented no, quantifiers existed as a concept back in the time of Leibniz. I don't know who invented the term quantifier. It's not a great term. Okay, so we've got these wrappers. They can be around either entities or properties. Actually, not just entities. They can be around molecules. And
molecules, external identifiers.
Right. Okay, so that's what goes in. That's the thing that goes in. What comes out... Oh, I see. I see. So what comes out is then... Okay, so a typical form is something like Oh, now I'm really confused.
What you want to come out is your new data series concept.
I know. But so then it's okay. So this would be qualified, let's say, of thing, comma, qualifier value, pressure, arrow, blah, 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 comma. No, this isn't right. This isn't right. Because that's a oh, no, I see.
No,
I see,
there
I
are
see.
5 other parameters which are not specified.
It's pressure, arrow, all.
You could keep the pressure concrete, but temperature might be variable.
Okay, but so then what you would do is you would say pressure, arrow, this, temperature, arrow, all. And that would then return a data series.
Okay, this one I feel like is now a little bit tricky because now you would have to internally specify what happens if we don't have this pressure value. But that's a technicality.
Yeah, I think it's a technicality. I mean, it can just error if it, but then, you know, what we need to be able to represent is, you know, nearest to that. Or something. Now, we might also want to average over all pressures. We might want this as a function of temperature averaged over pressures.
Yes, that's related to a comment from last time, where basically the qualifier syntax resembles the implicit entity class syntax, and therefore one could expect on the right-hand side any kind of operator. Yeah,
I understand. Right. Give results like averaged over one quantity, etc. CF implicit entities. So what you're saying is we should think of this as an implicit entity, or possibly an aggregated implicit entity. So for example, let's say I say, well, let's say I say take largest of 3, 5, whatever. That would give me the data series. I don't exactly know what that would return.
A 2-dimensional data series that is indexed by some pressure values, the 5 largest, and for each of them a temperature series.
Yeah, I think that's right.
Yeah.
That's an interesting suggestion from Icy on our live stream. Is this an operator form?
Yes.
I mean, that does raise the question of qualified with a list, which I think should just work.
I agree.
All right, so
if these things are in this additional list, this makes it reasonably clear. This means, yeah.
Right. Okay, so look, I think here's what we should do. Why don't you try and sort of clean up the concept of this qualified thing?
And I don't really like series.
What's that? And the data
series. The data series, I think we have to do some thinking and playing around this.
Right, and what its operations would be, which will be analogous to the operations of, they would be multi-dimensional analogs of the operation of time series, but that should also be looked at with respect to the geo stuff, the new geo statistics stuff, which will already have 2-dimensional things which have to be projected in various ways. Although in that case, the 2 dimensions are, you know, are very spatial.
Yes, so all the examples that currently return a list of qualified value would instead return a data series.
Yeah.
Right. And here, this footnoted concept, I think, is also worth looking at. And what that would be effectively is in the outputs, one of the aggregators, one of those third argument aggregators would be something like footnoted. I don't know if that's quite right. That's not quite right. That's not quite right. But the basic point is I mean, just like, to me, some physical quantities, it's worth returning their around values. Sometimes, okay, so, this is a choice of values returned, right? And the things we could return, okay, one case is, case one, include multiple values of other qualifiers, of other qualifiers, or qualifiers in general. In other words, you think the value, what's the population of London? Well, don't return one thing, return its time series across, dates or something. Case two is return around, return footnoted. What else might you return along those lines? I mean, in principle, you could return a probability distribution, some normal distribution or some such other thing. For a few things, that might make sense. I mean, particularly in, I don't know, in some quantum mechanical thing or something like that, one could imagine returning that. But those are the most obvious things to return here. Where these are, those behave like a single number. Yeah, I mean, there's also a question of how this relates to data set, which is, the relation between data set. Okay, so this is a question. Relation, actually, this is a good question. Relation of data set to data series, because they're actually very similar. Right? In fact, maybe data series should just be a data set. But normally in data sets, we're thinking about them as discrete data. We're not thinking about them as being interpolated.
Can you feed a data series to get an interpolation function out of it?
Well, one would hope so.
Okay.
Ethan is saying that pandas already models hierarchical time series. I'm not sure how true that is, but I think that's a slightly different thing of doing. I don't know, but we could certainly look at that. But you know what? I think this is actually a good observation.
But I think that the one difference to dataset that you earlier objected to was dataset would have the repetition of what it is in some sense.
Why?
Because dataset doesn't have this disassociated row of or column of just values. If you go back to the Wiki data water example, like what would be the left-hand side? What would be the key for the 1.3?
Some generic key.
Oh,
I understand that this
okay.
is, I mean, alternatively, a better way to think about it might be, no, actually, I'm changing my mind. This whole thing here would be in the key, and these would be the values.
Oh, okay. I didn't think this way. I thought more like each of them becomes its own row or column.
Well, I'm thinking, I mean, data set right now is not familiar with having a lot of stuff packed into the keys, but it could be.
And for two qualifiers, would we just have a flat, long data set?
No, I think once there's a qualifier, this one doesn't have qualifiers. This one is just, well, if it was, look, if this was presented as qualifier and value, then this becomes the key. With two qualifiers, I would imagine two columns that are keys and a column that is values. No, that doesn't make sense.
I think your earlier the idea of a very generic or special key.
Yeah, it's a better idea.
Work, not bad. Value, result, whatever.
Or some symbol name.
Exactly.
All right. Well,
okay, so I think
well,
kind of we have
another
anyway to
iteration.
do some
Yes.
thinking about this. We have to meet with Jose about data set.
There's comments about data frames being composed of series. Yeah, I mean, it's complicated because if you think of, yeah. Okay, good stuff. All right.
Yeah, thank you.
Thanks.
The great. I think Andre is commenting on unstructured time series. Absolutely, we have that. Anyway, thank you, people here, and thank you for people on the live stream. Thanks for the comments. Very useful. And we'll continue another time. Okay.
Thank you.
See you all.